Welcome back to part 3. We just finished doing the left Riemann sum of 5 equal subintervals, and now we're going to do the right Riemann sum with 5 subintervals. See if we get something a little bit different than 480. I'm not saying it'll be more or less. It might even be the same, but chances are it'll be different. So this is our second out of 4 different ways I'm going to show you. Okay, using a right Riemann sum with 5 subintervals of equal length. Again, our x-axis or our t-axis is going from 0 to 10. So our delta x or delta t in this case is going to equal b minus a over n, which is our 10 minus 0 divided by 5 equals subintervals, which means each subinterval is going to be 2 hours long. So we are going to chunk up between 0 and 10 into 5 subintervals. Each one is going to be 2 hours long. So from 0 to 2, from 2 to 4, from 4 to 6, from 6 to 8, and then from 8 to 10. Each one of these represents a subinterval of 2 hours long. And that's going to be considered the base of each of my rectangles from each subinterval. Okay, so I want 5 subintervals. I'm looking at the area of a rectangle is base times height, plus the area of the second rectangle being base times height. The third rectangle will be base times height, the fourth one, and the fifth one. Oh, you see how I did that, did you? Okay, so I want to add 5 different rectangle areas together to get a total distance. So now, I have my first subinterval between 0 and 2, and I want to use the right Riemann sum. So the right side of this rectangle that I'm going to form is going to be all the way up here at 80. So it's going to be 2 times 80. And the second one. Now I'm going to jump over here. I'm going to use my chart instead of my picture now. So I have an interval of 2 for my base, and then the 80 for my height, because I get to choose between left-hand side or right-hand side, and I wanted the right Riemann sum, so I picked 80. And now I'm looking at my interval between 2 and 4 hours, and this time I'm going to use that 40 as the right side of my rectangle, so 2 times 40. Plus, and now I have a base of 2 again, and my height is either going to be 40 or 60. I want the right side, so I pick the 60, plus 2 again for my equal subinterval. Okay, I think I mentioned already, but I'll mention it again. These subintervals don't have to be equal widths in order to have a Riemann sum. They could be varying the size of the bases of each rectangle. So on my fourth subinterval, I have a base of 2 and a height of, take the right side, which is 40. And then my last subinterval is still a base of 2 and a height of, in this case, 0. Which means that this last rectangle right here is actually nothing. Okay, I'm going to factor out my 2, and I'm going to be left with 80 plus 40 plus 60 plus 40 plus 0. And I always like to count and make sure I have 5 numbers in there, and I do. So I'm looking at 80 and 40 is 120, 120 and 60 is 180, and 180 and 40 is 220. So I'm looking at 2 times 220, which is 440 total miles, because every time you do a base times height, your base is measured in hours, your height is measured in miles per hour. The hours cancel off, you're just left with miles. Again, rate times time equals distance, so now we have total distance right here. And this would be the answer to my second way, which is known as a right Riemann sum. And that's 440 miles. And I think we can pretty much keep going a little bit here, and I'll give you my third way, since our video, it hasn't gone too long yet. Our third way here is, instead of a left or a right Riemann sum, we're going to use a midpoint. Let's see if I can fit the word midpoint. How about abbreviating MDPT with 5 subintervals again? Let's see, we are looking at 5 subintervals with a midpoint Riemann sum. And I'm pretty sure you can guess it here. Let me erase all my circles. because my finger works better. Alrighty. So, I have my subinterval between 0 and 2. I use the 20 for the left side, I'm going to use the 80 for the right side, and I'm going to use the 60 for the midpoint. That should make really good sense to you. The base is a 2 and the height is going to be 60. Now see how that focuses back over here in my picture. Instead of going for a left side or a right side, I'm going for the side that has the point smack dab in the middle. Should give me a little better approximation. If I'm not at the lower or the upper, I'm somewhere in the middle. And hopefully that's always going to be the case. So I'm going to use the height of 60. It's not the right side Riemann sum, it's not the left side Riemann sum, but it's somewhere in the middle. It's for the 1 hour mark at 60. So I don't have to continue to look at my chart or my picture. I can just do all my work now from my chart. It's a little easier to do that. My second interval goes from 2 to 4 hours, and I use the 80 for the left Riemann sum. I use the 40 for the right Riemann sum. And yes, indeed, I'm certainly going to use a 70 for the midpoint Riemann sum. So plus 2 times, my 2 is my base. Instead of the 40 or the 50, I'm going to go for the, instead of the 40 or the 60, I'm going to go for the 50. And what will this height be used as? I'm hoping you said 70. And the last one will be a 2 times 30. And again, we can add all this up. I'm going to factor my 2 out from every single one of these terms and have 60 plus 70 plus 50 plus 70 plus 30. And I wanted 5 subintervals, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I haven't lost anything, so I'm still good on 5 subintervals. Let's see, what's this give me? 60 and 70 is 130, 130 and 50 is 180. 180 and 70 is 250, and 250 and 30 is 280. And then 2 times 280 is 560 miles. Looking at 560 miles for our third way, which is a midpoint Riemann sum. And that's 560 miles. Remember that all of these are approximations. Not exact answers anyhow. Okay. How are we looking at our time? 8 minutes. Okay, I think I'm going to go with the fourth way then, and we can wrap this all up. So our fourth way is not going to be the left Riemann sum or the right Riemann sum or the midpoint Riemann sum, but instead of even doing rectangles, I'm going to chop this thing up into a few trapezoids and see what happens with that. In order to create my trapezoids, you have to understand what the area of a trapezoid is. So let me erase my circles along here. Now everything's been circled, hasn't it? And I have all my 2's. Erase all those. There we go. All right. To find the area of a trapezoid, okay, the formula says 1/2 the height times the sum of the bases, and this gets just a little bit tricky. Okay, I have a little tool that's going to help me explain this to you just for a second, so I'm going to step off and see if I can find my little fun thing. And here it is. I just want to explain this formula for the area of a trapezoid real quick. Like, I have a trapezoid sitting here. Whichever way you'd like to look at it, I'm going to look at it this way. So I have a trapezoid, and what defines this as being a trapezoid is it's a 4-sided figure with exactly 2 parallel sides. The top and bottom in this case are parallel, and the left and right are not parallel. But I can turn it like this, and it's still a trapezoid. I can turn it like this, it's still a trapezoid. I can make it go diagonally, and it's still a trapezoid, as long as 2 out of the 4 sides are parallel, and the other 2 are not. The 2 sides that are parallel are called the bases. And what I can do is I can take this trapezoid, which kind of looks like this, in a way. And it's hinged. I don't know if you can tell I made it with two by 4s. What I'm going to do is I'm going to chop it in half and bring it out like this. When I do that, I end up with a parallelogram. And that parallelogram is as long as whatever the bottom base and the top base add together. So I am touching both of the bases right now, and as I open this up, my bases are joined together to get the length of the parallelogram. And that is why we add the two bases together. To get the total length of the parallelogram, this becomes base 1 plus base 2. And what's this height of the parallelogram? Well, it's half the height of what the original trapezoid was. So this is your 1/2 height. And the area of the parallelogram is the same as that of a rectangle, so it's just base times height, or height times base, but it's 1/2 height times the sum of the bases. Let's not forget, with a trapezoid, the bases are the two sides of the quadrilateral that are actually parallel. Alright, now this gets a little tricky because when I'm over there in my picture, the bases are not up and down from each other like I showed you here. You can see that the bases are going to be parallel. They're going to be the two sides, what would have been the left or the right side of each of my trapezoid. So left and right side, left and right side, left and right side, left and right side. So my bases, when you deal with the trapezoid function, the bases are actually the height of the function. So they're actually velocity values and not time values. The height of my trapezoid is going to be the distance between the two bases. This base is parallel with that base, and the distance between the two bases is a 2. So it's a little bit different. We have to kind of twist this a little bit. But once you do a few of these trapezoid questions, you won't be so confused. Plus, I have a little trick for you at the end, so hopefully you won't even need a trapezoid method, but you may. Okay, so I would like to use, I'm going to erase this, and I'm going to say 4th way. And we are going to use a trapezoidal. Let me just see, I think it's still called a Riemann sum. And we'll still use 5 equal subdivisions with 5 equal subdivisions. Okay. That's a high number for trapezoidal approximation. Normally it's 3 or 4, but we can still do 5. So I'm looking at the area of a trapezoid plus the area of the second trapezoid plus the area of the third trapezoid plus the area of the 4th trapezoid. And am I going to run out of room here? I think I am. So I'm going to have to put the area of the 5th trapezoid here. There we go. 1, 2, 3, 4, 5. We'll fit them all in there. It'll work somehow or another. Okay. So again, I want to take the interval between 0 and 10 and divide it up into 5 equal subdivisions. So I am looking at going between 0 and 2, still 2 and 4, 4 and 6, 6 and 8, and 8 and 10. And I want half the height times the sum of the bases. Half the height, and then the sum of the bases. Let's go ahead and take a picture at our first subinterval, and take a peek at our first subinterval. This is representing one of the bases. This height is representing another base. Those are my two bases that are parallel. The trapezoid is actually this picture right here that I've bolded right now, nice and big for you. Here's your trapezoid. Base 1 plus base 2. This is your height. Your height is a distance of 2. And the height is going to be consistently 2 now, just like the bases used to be consistently 2 when you were dealing with a rectangle. So 2, and then one height is a 20 and one height is an 80. So I just do 20 plus 80 plus 1/2. My height is still a 2 because it's the distance between my, my two heights here. So my second trapezoid, this would be the left side of it, this would be the right side of it. These now are the two parallel pieces. The distance between the two of them is 2 units wide. So therefore the base, not a base, the height of my trapezoid is now a 2, just like it was here. This was a height of 2 and a height of 2, but my two bases are now 80 and 40. My trapezoid would be like this. That's the trapezoid that I'm finding the area of. It's 1/2 times 2 times the sum of 80 plus 40. So 80 plus 40. Plus 1/2 times 2 times, and I did 80 plus 40 last time, and this time I'm going to do 40 plus 60. 40 plus 60. Plus 1/2 times 2 times, this is my 2, so my height, one of my bases would be a 60, my other base would be a 40. The height between the two is going to be a 2, so 60 plus 40. And lastly, 1/2 times 2, and then 40 plus 0. 40 plus 0. Let's just take this middle one here, this fourth trapezoid over. So my fourth subdivision. So 1, 2, 3, 4. Let's just look at this again. You can see the two parallel sides that make up your bases of your trapezoid. One of those bases is a height of 60, the other is a height of 40. And the distance between the two bases is known as the height of the trapezoid, and that's a 2. So when I fill in my formula, I got 1/2 the height times the sum of the bases. So 1/2 of 2 times 60 plus 40, and you see that written right here. Right? Again, trapezoid's a little weird because it is kind of flipping things between what used to be a base and what is a base now with a trapezoid. But 1/2 times 2 in each case is gone. What's 20 plus 80? 100. What's 80 plus 40? 120. What's 40 plus 60? 100. And another 100. And 40 plus 0 is 40. I add these up. I get 100, 200, 300, 420, 460. This is a total of 460 miles. And that is my fourth way of doing this that we are going to discuss in class. And that is a trapezoidal Riemann sum. And that is 460 miles. Do you notice that that 460 just happens to be the average of 480 and 440? And it is going to be the average of your left Riemann sum and your right Riemann sum will end up being your trapezoidal Riemann sum every single time. So if you ever want to really, if a question on an AP test asks you to do a trapezoidal sum, you have to do the trapezoidal sum. But you can always check it by doing left and right and finding the average and make sure that you have the value smack dab in the middle between 440 and 480 is 460. So again, go back to your chart, use it as much as possible, left, right, middle, very, very simple to do. You get a little hung up with the trapezoid because it twists, and instead of using your base as your time, it's your actual height becomes your time, and your bases are your two parallel sides, which are your two velocities. It does mess it up just a little bit, but it's not impossible to do. All right, we're going to wrap up this, and this is still a part 3 video. Thank you.